This is a revision video for triple students on investigating light. So when we do this in the classroom, we turn the lights off because we're using ray boxes. It makes it a lot easier to see the apparatus and the rays. So that's my first suggestion for this practical. So to investigate reflection, what we do is we set up our mirror or our object to be reflected on. So I'm just going to draw dashes lines on this line to represent the mirror surface, the mirror plane. We use our ray box as our light source, and we have our incident ray coming in. And what I do is I've drawn where the mirror line is going to be. I'm going to place the mirror there, and then I'm going to I'm going to trace over my incident ray. And where that collides with the mirror surface, I'm going to draw a normal. And then I trace over the reflected ray using pencil, and then I can measure my angle of incidence and my angle of reflection. And like in the earlier video, we should see the angle of incidence equals the angle of reflection. And this is true for flat, smooth surfaces such as mirrors. If it's not smooth, we may end up with something called diffuse reflection. So for example, if we were to use paper there instead, and we were to repeat this experiment, the incident ray would come in and the reflected ray would be a little bit wider. It would come out just a little bit wider, and I've exaggerated it in my picture. And the angle of incidence and angle of reflection should still be the same. It would be a little bit more difficult to measure it accurately using a protractor because it's become diffuse. So what we call this is diffuse reflection. And this occurs off materials that are not smooth, so paper, stones, cotton t-shirts, etc. Whereas specular reflection, where it's perfect, is off smooth surfaces like mirrors, glass, metals. So that's how we investigate reflection. So how do we investigate refraction? Well, it's very similar. We have the lights off and we use ray boxes. So first of all, I'll get a big piece of paper and I'll put my object in the middle and I'll draw around it. So let's just say we've got a rectangular glass box. I would then set up my ray box. I'm just going to call it ray to make it short. Angle my incident ray onto my block, tracing over it with pencil. I would draw my normal. I'm just going to label it N to save space. I would then trace over where it leaves the block. Again using pencil. Move my block out of the way and I'll join up where it enters to where it leaves. Draw a normal from where it leaves. I would then measure my angle of incidence and my angle of refraction. So this would be my angle of incidence. It's between the incident ray and the normal, and my angle of refraction would be between the normal and the refracted ray. We can't see there properly, so I'm going to zoom in. So if that was my normal, my incident ray has come in like that. So that's my angle of incidence between the incident ray and the normal. My ray has changed direction because it's slowed down, it's gone into a dense medium. Between the normal and my refracted ray is my angle of refraction. And that angle of incidence and the angle of refraction will not be the same. They are not constant. And this experiment we could repeat with different shaped objects. We could repeat with different materials. And these angles of refraction would change with different materials depending on how dense they are. The greater the density, the more the speed of the light would slow down. The more it slows down, the more it's going to change direction towards the normal. Depending on the shape of it, you may get a different pattern. If you had a prism and you had an incident ray coming in, it would then change direction towards the normal, and then as it's leaving, it would go away from the normal. If we were to shine a light directly along a normal, doesn't matter what shape, I'll show this in a second. So there's our normal. If we put our incident ray along that normal line, all that would happen is the light would just go straight through in a straight line. And this would be the same if it was a semicircle, normal, line going straight along and through. And if we did it the other way round, it would go straight through. I'll show this now. Semicircle, normal. If you shone the light there, it would just go straight through, it wouldn't refract. If we had a normal there, because remember 90 degrees, it would just go straight through. On its way out of this one, it would then go away from the normal because it would be speeding back up into the air. So you need to know how refraction occurs for different shapes, different materials. Just to recap, put a piece of paper down first, put your block in the middle, turn the lights off, put your ray box, shine it on your shape or your material, trace over the incident ray, trace over the ray leaving the block, remove the block, join the lines up, draw the normal, measure the angle of incidence between the incident ray and the normal, measure the angle of refraction between the normal and the refracted ray, then you change whatever your independent variable is, whether it's the material or the shape of the object. And if you're changing the material, the denser the material is, the more it will slow down that light ray, therefore the more it will change direction towards the normal.